Good morning, good afternoon, good evening, everyone. Welcome to our second webinar in our 2025 IEEE Metaverse Grand Challenge series. That's the initiative dedicated to exploring transformative power of simulation-based learning and immersive technologies in advancing real-world solution for healthcare systems and education. Today, we will go to focus on the how to design the digital healthcare experience. Actually, we have today invited speaker, Professor May. That's a great opportunity for us to listen her talk. Actually, she will just provide a talk about how to use like kind of opportunities for metaverse in healthcare. I am delighted to introduce our distinguished speaker for today's session. Just briefly, just want to introduce her actually before providing the floor to her actually. Dr. May is a Wallace Coulter Distinguished Faculty Fellow and full professor at Georgia Institute of Technology and Emory University in Atlanta. She received her bachelor from Tsinghua University, China, and her master and PhD from Georgia Institute of Technology. She is director of Biomedical Big Data Initiative and Georgia Distinguished Cancer Scholar, Board of Directors of American Board of AI in Medicine, Pettit Institute Faculty Fellow, Calvin Fellow, AMBA Fellow, EMBA Fellow, and IEEE Fellow. Dr. Wang works in biomedical, big data and AI, health informatics, and metaverse for predictive, personalized, and precision health. She published over 330 articles in reference journals and conference proceedings with about 19K Google Scholar citations and has delivered more than 340 invited and keynote lectures. She was awarded Georgia Institute of Technology Outstanding Faculty Mentor for Undergraduate Research, IEEE Award for a High Impact Paper cited over 1,000 times. Dr. Wang is a senior editor for IEEE Journal of Biomedical Health Informatics, associate editor for IEEE Transaction on BMA and IEEE Reviews in BMA, and a panelist for NH CMDA Study Section and NSF Smart and Connect Health and Brain Canada. She is serving in Metaverse Initiative Steering Committee of Future Directions. Yeah, please join me in welcoming Professor May. Yeah, that's floor your side actually. Thanks so much.
Okay, thank you very much. Thank to Javika, Sinkun, and Paulette for inviting me to speak to you all. And good morning, good afternoon, good evening, anywhere in the world. I'm so excited to have a chance to share with you this fast-growing area. And so the talk today is meant for inspiring the sparks among yourself. And then I'm very happy to answer questions towards the end of my talk. I think that the key concept here is designing the digital experience. Metaverse for healthcare is only one application area for healthcare because I am working in the healthcare area. That's why let me actually give you a perspective because for the technology to make a real impact, we have to understand and know what is the goal for healthcare. So in the earth, we always have two important pieces to consider. One, as a human species, for us to survive in the earth, that's the population. The other one is each of us will have health challenges throughout our life. So that's why over the years, there are a lot of technologies being invented to measure the data. That's actually usually being titled as biomedical engineering or biotechnology. The goal is to collect as much data as possible. And then with the goal, fundamentally, is to have a healthy, long life. That's why we call it predictive, personalized, participatory, precision health. And then Metaverse happened to be an important catalyst in this whole process. It's actually a different name for combining artificial intelligence, virtuality, augmented reality, mixed reality. And then in terms of the whole goal of predictive, personalized, precision health, they all play a role. But with Metaverse technology, one key contribution is participatory. So this is where I'm going to focus on. I do want to use this opportunity to quickly clarify that when we actually talking about metaverse, it's not a simple digital simulation technology, which has been existing ever since probably close to 80 years. We're actually talking about metaverse. It has to have a carrier. This carrier has to go beyond purely a simulation. So for myself, Palata already introduced myself, but I do want to highlight an important thing. As he mentioned that I did have my undergrad from Tsinghua University in China. I came to Georgia Tech, finished my PhD, but I do want to highlight, I did have an opportunity to work in Lucent Technology Biolabs industry for a few years. This actually highlighted a unique perspective of our research. Because coming from industry, we care more about impact and beyond just academic publication. So that's actually is behind this metaverse effort we made over the years. So this is my lab at Georgia Tech and Emory. And also, as Paulette highlighted, I happen to be honored to work with distinguished colleagues in our large community, including IEEE Future Direction Committee, and also including the Metaverse Initiative Steering Committee. At this particular moment, we did finish Metaverse for Healthcare article. Right now, it's in the middle. We're going to submit to Nature Digital Health. And if not accepted there, we're going to publish in IEEE Journal of Biomedical Health Informatics. If some of you do a little bit of research, you can find out that the IEEE Journal of Biomedical Health Informatics is absolutely the top 2 medical informatics journal in the world with the impact factor of more than 70.7. Meanwhile, I do want to highlight, beyond my industrial background, I'm very proud to have an opportunity working with a group of clinicians. So this is a society largely formed by clinicians. I'm actually right now elected a board member, helping to move the needle ahead. Okay, so talking about myself, I keep emphasizing industry. I also emphasize the medical community. This is where I work on a daily basis. I'm in Atlanta, Georgia, which is actually where the Gone with the Wind, the novel, where that came from. If you're looking at the 1996 Olympic in Atlanta, that's where I am. But I'm very fortunate to be with this unique setup. This was the first time ever in the US history, 2 universities are working together, forming one academic department. So on the left is Georgia Tech, my department building. On the right is the Emory University School of Medicine, our department building. Among the more than 160 biomedical engineer department in the whole US, we're the largest, and meanwhile, we're the top 2. We're number 1 and number 2, undergrad and the graduate school, always with the Johns Hopkins like department. What I do want to highlight is among everything we did from the entire healthcare span, from imaging, from system biology, from tissue engineering, general medicine, cancer, cardiovascular, neuro, immunoengineering, robotics, and currently our top focus is grow the AI. So with that as the background, let's actually dive into detail, the metaverse, right? As I mentioned that, I started my graduate school at Georgia Tech. Started part of my graduate study was actually working on virtual reality. At that moment, no augmented reality yet. And then later on, I move on to multimedia computing, then come back to do biomultimedia research. And then during the COVID, we pick up the early day what I did, except we extended it to include not only virtual reality, but augmented reality and artificial intelligence. That's where we actually officially call it the metaverse. So how metaverse is related to healthcare, right? Why metaverse is disruptive? Why do we need a metaverse? What does a metaverse do? What are we currently doing, right? These are a lot of questions while we're defining metaverse. And so fundamentally, if you look at for the last 18 years, what's happening at this moment? This is the real world. Remember, today's talk is focused on the digital experience, right? So this is the real world. And then now we start getting into the digital world. Originally, when we moved from the digital world through the industrial revolution, we actually focusing on 3 areas: computation, communication, and the storage, right? And in this whole process, this is communication, the phone, computation, the computers, and storage. And what's happening is, over the years, there's a need going from the infrastructure, fundamental transformation now, to individual experience. That's why you're looking at this immersive visualization, haptic devices, and the holograph, right? So that's whole thing is people currently call it extended reality. It was not there when I was doing my graduate study at Georgia Tech, but actually did like a progress over the last couple of decades, right? So that's where we're calling it a metaverse. So if you look at it, the entire transformation is from digitization, digitalization to ultimately the digital transformation. If you look at in this whole progress, as I already said, this is not just a simple simulation. It's actually involved hardware development over the year. From the beginning, the first commercial virtuality, that's around the time when I was in graduate school, to the first use of VR in the healthcare, and then from the rapid expansion of this into the telemedicine, now we actually see exponential grade, like a growth, right? And then now we're getting into the metaverse, right? So fundamentally, you look at like a different color, right? From the digital world to the real world, I expand what I showed you earlier, the computation, communication, and the storage to the currently the metaverse, right? And if you look at what's happening, there are many things happening. If you're talking about computation itself, we're actually looking at evolution. But if you're actually talking about the metaverse, one of the key enabling fact is we're actually democratizing these kind of devices, make it possible. Without these devices, you cannot call it a metaverse. It's still the traditional simulation, right? You need to go beyond that. And then we're trying to bridge the real world and the digital world. And then there are a lot of benefits of metaverse. There are a lot of benefit to healthcare, where I'll give you a couple examples. Ultimately, this is why it's a disruption of technology that's bringing a more transformation to our society, right? So that's why I already emphasized a couple of times, right? When we're talking about metaverse, we always have to remember it's significantly related to this personal experience with some hardware assistance, right? So then, specifically in the healthcare area, and we have been leading the effort. It actually triggered during the COVID when I was serving in a working group led by National Science Foundation, looking at how the remote technology could bring care to home. And so ever since then, we started this process. And then the field has been very fluctuated some because the field also after COVID was driven by entertainment and other industry. So that's why only recently we finished the entire like upgrade. That's where that publication is going to be submitted. As soon as it's submitted, it's going to be shared with our young professional community, because I think a lot of the resources you can find from that article. Specifically, as I already said, without the hardware technology, it's not a real metaverse. It's only a simulation, right? Right now, we're trying to bring that. So there's a fast growth over the years in terms of the hardware technology development. And then before COVID, including when I was a student, we already start using the technology in the digital world to create the reality. But however, in the healthcare area, it's kind of limited. For example, back then we work on height phobia for people who are afraid of height. We give them the goggle, we program it so for them to train to deal with that, right? So then if you look at the before COVID-19 pandemic, rehabilitation, mental health, primary care, surgery, and HIV infectious disease, chronic disease care, a lot of them are done by in-person. As I mentioned that, the reason I picked this up is during the COVID, we have an NSF a working group. We're looking at the technology, how to move some of this remotely because COVID was highly infectious. So we want to reduce the spread of the COVID by bringing this in. So the social distance has triggered the push for technology, right? The social distance and quarantine. As a result of it, we're looking into the technology, and among all the technologies, Metaverse, back then it was still called extended reality. That consists of the three things, as I mentioned: immersive visualization, haptic, as well as the holograph, was actually triggered to pick up the speed again. And also 2 years ago with the AI kick off again, so AI was incorporated with XR. Now it's officially tokened as Metaverse. So what's happening in the AI? This is a one thing I give a talk, a keynote, talking about the three bumps, right? So AI 1956 goes to the first winter, second winter, now go to the third summer right now. We want to keep it longer, right? So one of the things in terms of AI, how to prevent winter, is related to the AI impact. Believe or not, Metaverse is playing a role in this area when we're talking about the prevent another AI winter, because a lot of AI technology, the simulation, if it's not being adopted and utilized in the real world with a real impact, then it's not going to be able to survive. All right, it's probably we're going to go another winter. So that's the whole reason why this became another push for the Metaverse to fast grow. As a result of it, this is the world map to show you what's happening, right? Industry in the orange, a lot of big companies all are doing it. Microsoft, Google, Meta, they're competing to make the hardware light. Then if you look at the all this different on the academic side, there are a lot of universities like my group also pick it up, industry, academic. Meanwhile, also this is a world map. All the government also have started picking it up from US, Europe, and Asia, right? So that's why, because of this, IEEE started this like a Metaverse initiative under Future Directions Committee, started in IEEE, right? That's where Synquin and Javika and Celica, they are the one leading this initiative. If you look at it fundamentally what's going on, we're talking about a lot of this axis represent the technology created the data. This axis represent the impact. And this axis is where the innovation happened. And happen to be the Metaverse is on this innovation axis. Now let's coming back, talking about it. I think you are all interested signing up for this is because you want to join the Metaverse, right? As I said, I give you the background, I give you the history. You know that we're in the time where we're trying to showcase the AI with a mixed reality, fundamentally Metaverse is going to make a real societal impact, right? You're joining this right now. This is the right time. By doing this, you are going to open your career tremendously. More importantly, you're going to make a real impact. By joining the Metaverse, there are multiple areas you can personally decide to focus on, right? Focus on the immersive visualization, focus on haptic device, focus on using sensor. Then coming to the Metaverse field, you actually adopt the AI, bring the AI technology, combining with the technology to make some of the impact. So that's why at this moment, in the healthcare area, right, here are 4 very prominent areas in the field. One is on the education training, one is on surgical planning, One is on rehabilitation, one is remote telemedicine. What I will show you are just an example in 3 of the 4 areas, so that you have a rough idea what you might be able to do, right? So this was carried out by my team in Georgia Tech and Emory. I didn't put all the clinicians because we have many, many clinicians also involved in the process, but these are really young professionals like yourself, right? So actually early days, we actually even got, when Javika Synchro and they organized the meeting a couple years ago, we got the best paper award, and because that's all lead to a real world impact, where I'm going to show you some of the examples next. Let's first talk about it, training. Traditional training, you have a cadaver, and then the surgeon work on cadaver and figure out what to do, okay? And then there's a push. People start saying we should use robotics, right? Same thing, robotics to pick up the speed during the COVID. However, the robotics is very highly expensive, very hard at this moment to make it in terms of surgery to automate the entire process. By the way, still make a fast progress right now. So that's why Metaverse coming in to play a role. So I want to quickly show you an example. So this is a very complex example to showcase how you need to use this to train surgeons. So this is related to spine surgery, because some people grow up with bone density has some issue. As a result of it, their spine can not like a healthy spine grow straight. They actually automatically grow to be curved. That's actually bring a lot of issue in terms of breathing, in terms of course, in terms of the healthy growth of the person. There are many, many issues going on, right? Traditionally, however, the way the surgical procedure used to do is they actually fix the spine. Basically, just have the spine originally curved. They force it to be straight, then they just adding all this long rod, the metal rod, to force it to be straight, right? Unfortunately, this doesn't apply to the younger the generation. For example, the kids who are still grow. The moment you do that, you control their growth, right? How do they grow bigger, grow taller? So that's why there's new surgical procedure being proposed called the tethering, which is instead of putting a long rod to force the spine to be straight, you're going to the local fixing. What's the problem for this? Clinical protocol, you don't have it. You have to do a lot of training for the clinician to figure out how to do it and simulate how is the growth of the spine and how to deal with this, right? So the new surgeon, the resident need to get a training. So at this moment, I'm just showing you if you are the one doing this, how you can use it. But it's of course it's not complete yet because this is such a complex procedure. But at least I want to show you the metaverse, how it's being utilized for this kind of training purpose. The training purpose is, if you look at this is the natural the spine, and then so in this metaverse environment, you are able to utilize the training. The surgeon is able to utilize this metaverse training to go ahead and put a needle for local training without having to put a rod to force it straight at once, right? So this is actually one example why metaverse is critically needed right now for training the new surgeon. Once the training process is done in the future, is that possible to be utilized for surgical planning, for sharing with the patient? Of course, but this moment, because this is a new procedure, that's why it's largely utilized for training purpose, okay? Second one is surgical planning. So this one is the one, again, traditionally you do surgical planning. There are a lot of talking, honestly, even it's the surgical procedure, but a lot of it just plan talking. Maybe some on the paper drawing, right? So now with Metaverse, this is what's happening. Again, this is showing how you combine with the state-of-art AI to do it, right? So in this whole process, the clinician, the surgeon, need to actually plan how to do. This is for a facial surgery, right? How to plan it. So fundamentally, they have this CT originally, and based on CT, you reconstruct what's the skull look like. Now you have to move the skull. Why it's important for surgical planning is because how much you move the skull directly impact how the person look like after the surgery, right? So that's the reason why in the past it's all just talking and some drawing roughly. Right now, you can use Metaverse combining with AI. By the way, what you just see here is a combination of ChatGPT, large language model, with the Metaverse. So that's why the AI is directly incorporated in this surgical planning process. And then the next one, rehabilitation. So again, in the past, when you do rehabilitation, where we do rehabilitation, there's so many ways you do rehabilitation. I'm just actually showing one example, but I can tell you where a lot of time rehabilitation is being used. So for example, for senior people who have stroke, after stroke, they need to recover the movement. For younger people, the accident, traumatic brain injury, for example, if they are in the sports or fall down, right, on the bicycle, all those things can cause traumatic brain injury that require the recovery, right? So I'm just again here showing during the rehabilitation like a process. Traditionally, how those rehab are done. The way rehab are done is you have to have family member arrange transportation, take the patient to the rehab clinic, and then do a session for an hour, and then go home, right? So as a result of it, it's very expensive. Also, the frequency is very low, right? So that's why the metaverse, one of the major application impact area is rehab, where people can do it at home, right? So right now, I'm just showing you one example. This is for a small kids rehab for the upper limb, right? Upper hand. How do they do this? So fundamentally, once they have this metaverse on, and then all these spots are indicated how much motion, how much reach when they're recovering their hand, right? So then the person who is going through the rehab by playing this, right, going for different place, they're able. We can actually see how much they have recovered their movement. So this is another example to test how much they can actually doing a certain movement, right? And also the speed in reach out to the target. So these are just a few examples. I didn't put a remote consultation and telemedicine. And this one by far is the most advanced in the current clinical practice, especially after COVID. Just like now, I'm actually speaking to you in Zoom. There are a lot of clinics right now using the Zoom to do the consultation, so the patient do not have to come in, right? I didn't particular put this here because I do not have a ready a local developed demo to show you, but there are a lot of them on the website. You can actually retrieve to see how this works. So overall, the key concept in this entire metaverse is it's actually not only hardware must be included and plus AI. Together, we created the reality so that people at home, when anything deal with a medical issue, healthcare issue, can benefit by not having to go into the clinic. They can experience that. In addition to that, surgeons, the clinicians can also benefit without having without having the constraint of being constrained by cadaver. They can actually do training. And in addition to that, they can do surgical planning, right? So let me summarize. What I didn't show you today, one thing is related to mental health. Again, that's another area is easier to develop, which is you can actually, the simplest way, you can project a paradise, the ocean beach, play the music, right? And having that in your local home or in your office and to help you reduce the stress. But very importantly, we have now been able to start using a haptic device, create a sensation for that, right? So that's why in this particular area, there's much going on here as well, besides what I already showed you on the training. Overall, metaverse in healthcare is a very fast growing area. It actually sees a real impact. Of course, there's still some technology issue we have to solve. That's another reason why this particular metaverse challenge is a great opportunity for you to use your creativity to contribute. With that, I'm finished up my presentation, and also I'm opening up for questions. Thank you for your attention.
Thank you so much, Professor May, for that insightful and inspiring presentation. Yeah, that should be great for us. Just want to listen to the metaverse direction in the healthcare.